Hi guys, we are moving on to quadratic equations in this unit. We just finished talking about quadratic functions, and I just want to start. I know this isn't in your note paper that I gave you, but you don't have to copy this down, but you do need to understand this. So the first thing is understanding the difference between an expression and an equation. So if you look at these two situations here, the top one in red is an expression. It doesn't have any equal sign in the expression there, so it's just an expression. In green, because we've got this equal sign here, that's an equation. Now, a special type of equation is this last one, because we've got an equal sign, but we also have y equals and then an expression involving x on the other side of the equal sign. And when we have the y and the x in the equation, it's called a function. So in the last unit, we talked about quadratic functions. And our quadratic functions look like these guys in some case. And in this unit, we're going to take a look at quadratic equations. So it's going to look more like this, where we've got an equal sign and some number on the other side instead of the y. So we're going to go through the note here, and it's just important that you understand that as we start taking a look at this. So when we're looking at these questions, function or equation. So a quadratic function is a relationship that has an infinite number of points that satisfy the equation. So we've got an equation, it's y equals something, so there's an example of a function there. And when we figure out all the points that satisfy that equation, we end up with this parabola. If we were looking at a quadratic equation, that's an expression that we wish to solve. So it doesn't have an infinite number of solutions that make it true. So if we put -6 in there instead of the y, then that's a quadratic equation. So if we have that equation, we're trying to find what value or values of x can we plug in that make the right side equal to -6. Now, because we can graph that expression into a parabola, we can actually just figure out from the parabola what the answer to this equation is. Because if I go to my parabola, and you can see that I've got -6 in place of y. So there's my y-axis, there's -6. If I go from -6 across the parabola and up, there's one value of x that would give me -6. And if I went across, because it actually hits -6 at 2 points in that parabola, 4 would also give me -6 if I put 4 in for the x in that equation. So let's take a look at this. If I sub x equals 2 into this equation, on the right-hand side of the equation it would look like, so 2 goes in for the x, and if I calculate it, 2 squared is 4, times 2 would give me 8. 12 times 2 would be 24, so minus 24, and then plus 10. And when I figure all that out, it's equal to -6. So in this case, the left side equals the right side. And it should also be true if I sub in x equals 4. So if I try that, 2 times 4 squared minus 12 times 4 plus 10. So in this case, 4 squared 16 times 2 is 32. And that'll be minus 48, sorry. 12 times 4 is going to give me 48. And then plus 10. And when I calculate all those, I get -6. So same thing happens. When I plug 4 in for x, it's equal to -6. And that's not a shock, because we could see that on the graph. We could see where we were equal to -6 was at x equals 2, and x equals 4. When we find the answers to a quadratic equation, we call that the root. So we would say the roots of that equation are x equals 2 or x equals 4. Okay, so let's take a look at the next page here. Now, most of the time, it's easiest if we're actually looking for the x-intercepts when y equals 0. So math is always easier when a 0 is involved. We can always rearrange the equation so that one side is 0, and then look at the parabola that corresponds to it. So in this case, I'm going to graph this actually first. So I'm going to graph it, and then we'll figure out what the x-intercepts are. So the vertex is +1, -4. And the step pattern, it's just a normal step pattern. So the step pattern is 1, 3, 5. And if I graph this, so I've got the vertex at 1, -4. So there's the vertex. And then the normal step pattern. So over 1, up 1. Over 1, up 3. And over 1, up 5. And then it does the same thing on the other side. So it would look like that. And then I could draw my parabola through those points. So remember, it's a curve, so it's going to look like that. So that's what the equation y equals x minus 1 squared minus 4 looks like when I graph it. Now, if you remember the way that we used to solve these equations here, so if I put 0 in for y, remember when I want to find the x-intercept of that y equals 0. So if I rewrite that equation, and I put 0 in where the y is, and you probably remember how we would solve these. So we take a -4 to the other side, and it becomes +4. Then we have to take the square root of both sides. When we take the square root of 4 here, it could be +2 or -2. So we're going to put a plus or minus out in front. And then on this side, we take the square root, and you just get x minus 1 that's underneath the square there. So that means then that if I leave x on this side, and I move the -1 to the other side, it's going to be a +1, and then plus or minus, and the square root of 4 is 2. So if I take a look at the two different answers, I'm going to get x equals 1 plus 2, so x equals 3, or x equals 1 minus 2, which equals -1. And you can see that on the graph, my x-intercepts are at -1 and 3. So there's the connection between what we were doing before and what it looks like on the graph. So finding the x-intercepts is something we have already done, like we just did there. It's reasonably easy to find an x-intercept if the equation has the square completed. But completing the square isn't always easy. So sometimes when we want to complete the square, we can get decimals and fractions, and that makes it a little bit messy. So because completing the square isn't always easy, we're going to learn 3 other methods for solving quadratic equations. So the first one is to go ahead and graph it. And I could have picked out those x-intercepts by just looking at the graph. So to solve by graphing, you need to remember how to graph a parabola. Then you just have to see where it crosses the x-axis, because those are the x-intercepts. So remember to graph these parabolas, these quadratics, we want it in vertex form. So we're going to go through these 3 examples here, just so you see the steps involved. So in this first one here, it's not in vertex form, so I'm going to use the little formula here. So x equals minus b over 2a. So it's going to be 3. So minus negative 3 is going to be plus 3. And then 2 times 1 on the bottom. So x is equal to 3 divided by 2, so that's equal to 1.5. And then I'm going to sub that in to figure out the other part of the vertex. So y equals 1.5 squared minus 3 times 1.5 plus 2. Okay. So I've gone ahead and done the rest of the steps there to find the vertex. So x is 1.5, y is negative 0.25. And if I write the equation in vertex form, it's going to look like this. There's no number in front of the x squared, so I don't put a number here, and then I plug the vertex in. You can see, though, that even using the little formula here, I'm getting decimals. It's not easy to work with. And now I'm going to graph this. So I've got the vertex at 1.5 and negative 0.25. So right there. And it's the regular step pattern. So from there, I'm over 1 and up 1. And then I'm over 1 and up 3. So 1, 2, 3. And then over 1 and up 5. And I'm not going to be able to fit that one. So on the other side, over 1 and up 1. Over 1 and up 1. My over 1 and up 1 didn't work very well there. I went up a little too high on those. So over 1 and up 1. It's going to be there. And then over 1 and up 3. 1, 2, 3. That's going to be below the line there. Sorry about that, guys. So this one's going to be here. And this one's going to be here. So you can see the parabola hasn't been stretched or compressed. It's the same shape as the original one. And that's what the parabola looks like there. I'll just finish the sketch. And so this parabola passes through at 1 and 2. So for this one, I'll say the x-intercept equals 1 or 2. The next one here, now I'm looking at this equation here. I'll start with minus b over 2a. So x is going to equal 7 over negative 2. X is equal to negative 3.5. So y equals and you can see, same thing happens again. We've got some decimals involved here. That makes it a little more difficult to deal with. So if I square the negative 3.5 and then put the negative on there in front, it will be negative 12.25 plus 24.5 minus 12. And then y equals 0.25. So my vertex is negative 3.5 and 0.25. So if I'm going to write the equation of this parabola in vertex form, it's got a negative out in front here, so I need a negative here. And then it's x plus 3.5 squared minus 0.25. And if I graph that one, so negative 3.5 to 0.25. So there's the vertex. And the step pattern for this one, because it's a negative out in front, is going to be -1, -3, -5. So from that vertex, I go over 1 and down 1. And on the other side, over 1 and down 1. And then from that point, over 1 and down 1, 2, 3. And then over 1 and down 1, 2, 3. And we can't put the last point on there. So when we graph this parabola, it's going to look like that. And this time, my y-intercepts, sorry, my x-intercepts, this is where it crosses the x-axis. My x-intercepts are -3 and -4. The last one here, so start with the mode formula again, minus b over 2a. So this time my b is 6, so that's going to be -6. And then 2 times a, so 2 times -3. So I'm going to get -6 over -6, which means x is going to equal 1. I sub that into the equation where the x is, so I can figure out what y is. So 1 squared is 1 times -3 is -3 plus 6 is going to give me 3. So for this one, the vertex is 1, 3. And you can see that we've got a number out in front of the x squared. So when I'm writing the equation in vertex form, that -3 is going to be out front here. And I've got x minus 1 squared plus 3. So you can see in this case, my step pattern, that's normally 1, 3, 5, is going to be -3, -9, -15. So from the vertex, I go to the vertex of 1, 3, and then from there I'm over 1 and down 3, over 1 and down 9. So I'll estimate where that is. Over 1 and down 3, over 1 and down 9. 1, 2, 3, 4, 5, 6, 7, 8. I'll just estimate where that is there. Slightly off the graph. And on the other side, over 1 and down 3, over 1 and down 9. And then we can draw our parabola through those points. So you can see this one opens down like we would expect, and it's been stretched. So it's going to look like that. And you can see that we have our y-intercepts. Oh, I keep wanting to call them y-intercepts. These are our x-intercepts. And our x-intercepts are equal to 0 and 2. All right, so that's solving quadratic equations by graphing. We've got some questions that we'll work on tomorrow in class. Thanks.